All right, let's try to do this here for you kids. So the way you're going to fill these things out is you need to know that the protons, all right, plus the neutrons. Actually, I should have made that red. That's all right. This will work. Protons plus the neutrons are what make up the mass number. So I'm going to show that with red and blue make up purple. Okay, so these two things combine to make the mass number. The protons and the electrons make the charge. So the protons and the electrons make the charge. So blue and yellow make green. Look at that. Okay, so this and that come together to make the charge. All right, so sodium. If you look on the periodic table, you will see that sodium has the symbol Na, and it has 11 protons. This particular atom of sodium has 23 as its mass number. So this particular atom has 23. The protons is the same as that atomic number, how many protons sodium has. So that's 11. Probably should have done that in blue. The neutrons, therefore, if these two things, the red and the blue, turn into the mass number 23, if that's 11, then the neutrons must be 11 from 23, which is 12. So actually, yeah, let me do that in blue so you can see. So that's 11. That's 12. The electrons are based on the charge with the protons. So since the charge is +1 and the protons is 10, that means that in the charge, in the amount of protons versus electrons, the protons are winning by 1. So the plus means it's protons, and the 1 is how much they're winning by. So that means this has to be 10. Probably going to regret the yellow, but there you have it. Okay, that's how you do that. Next, let's do arsenic. So arsenic is As. So if you look on, actually, I don't know that that's arsenic. Is it arsenic? I think it is arsenic. Let me consult my periodic table. Some periodic table music. Do, 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 do. There is no friggin' signal in my basement. All right, there we go. Well, maybe not. All right, arsenic is, yeah, 33. So it's just arsenic. That's a long song for nothing. Arsenic is what we're looking at. The protons of arsenic, it's telling you right here, 33 protons. If you didn't know that, you can find it on the periodic table. It's the smaller of the numbers. So protons is 33. The mass is up here, right? So the mass number is right here, this purple thing here, right? So the mass is 76. And since red and blue make purple, if this is 33 and that's 76, then that must mean that the mass number, or the neutrons, is 33, 76 minus 33, which is 43. Right? 3 and 3 is 6. Yes. The electrons, since the charge is 0, come together with the protons and electrons. There's nobody winning that little election, so therefore we're going to go with the electrons being the same as the protons, which is 33. All right, there you go. Next one's calcium. Calcium, if you look on the periodic table, has a Ca. It's telling you the neutrons, but not the mass number or the protons. Luckily, the periodic table tells us the protons, and the protons are, according to the periodic table, for calcium 20, I believe. Let me verify. Yes, 20. So I got that from the periodic table. So calcium has 20. The mass number is the protons plus the neutrons. So 20 plus 23 makes for a grand total of 43. So that's the mass number, which goes up there. And then the electrons, since this has a +2 charge, I'm going to change my electron color to that orange. Maybe it'll show up better. This has a +2 charge. It's in the race between protons and electrons. The protons are winning by 2, so that must mean that this is 18. All right, number 4 has 92 protons. So whatever it is has 92 protons. And if you look through, you will see on a periodic table that uranium has 92 protons. All right. We do have a mass number, 238. So uranium 238. So that means that the mass is 238. And if we have 92 protons and 238 as our total, then the amount of neutrons has to be 146. So this must be 146 because this blue proton and this red neutron has to equal 238. The electrons, there is no charge here, so the electrons are going to be the same as the protons, and that means 92. All right, let's continue with aluminum. Aluminum has 13 protons according to the periodic table. So protons I'm doing in blue. So that is 13. All right, and then the neutrons we get from the mass number. So the mass number is 26. That equals the red plus blue. So therefore, the neutrons have to also be 13 because 13 plus 13 equals 26. The charge is plus 3, which means that the blue is winning by 3. So the yellow, if the blue is winning by 3, has to equal 10. And that's how we get that. And then the nuclear notation is just aluminum. Aluminum with 13 protons and 26 for the mass. All right, lead is Pb. Lead is number 82. So its protons is 82. So we got that taken care of. The neutrons you figure out from the 208. So if the mass is 208 and the protons is 92, that makes the neutrons the difference between those two, which is 116. So 116 plus 82 equals the 208. There is no charge for this, so that means the protons and the electrons will be the same. There's nobody winning that election. So that would make this 82. All right, and then I should put 208 up high for that one. All right. So I think that covers it, doesn't it? I'll do one more maybe. Let's do one more. All right, protons for this one's 35. So we go to the periodic table, and 35 is the element Br. So Br, guessed, is the element here. So that's bromine. And bromine has, by definition, the 35 protons. This has 45 neutrons, is already telling us. So the mass number will be what those two things are combined. So 35 plus 45 is 80, I believe. Right? And that means our mass number, the combination of these two things, is 80. Since the charge is -1, that means the electrons are winning the election by 1. So that means we need to, so if this had 35, this has to be 36 because blue and yellow make that charge. So 36 and 35. 36 is one more than 35. All right. I think that does most of this. I think that'll get you through it. All right. Let me know if that's not helpful. I think it is. And best of luck.